Welcome to our second lesson. Okay, so second topic for the mathematics in the modern world class. So for today's video, okay, so I'm going to discuss to you about the Fibonacci sequence. Okay, for your learning outcome, so at the end of the lesson, you should be able to first identify patterns in the nature and regularities in the world. Next is to argue about the nature of mathematics, so what it is, how, how it is expressed, represented, and used. Then the last one is to articulate the importance of mathematics in one's life. Okay, as continuation, so I want you to identify what kind of pattern does the following images represent. Okay, so here are those images. Our first image was this one. Next is this one. Next, the fourth image, and then the last image. Okay, what is something in common to those five images? What can you see? What pattern that they have? So, if we're going to talk about the types of patterns, those are under geometric patterns because as we can see, as we observe, so there is geometrical pattern na we can see in those five figures. Okay, so what kind of geometrical patterns? So that could be a spiral pattern. Okay, so very good for that. You're going to if you already identify what patterns we have for these images. Okay, so many mathematicians and scientists are fascinated by the deep and open mysterious connection about mathematics in the world or between mathematics in the world. So, meron ba talagang connection yung mathematics sa mundo? Okay, if we're going to look at the nature, there are numbers of all around us. Okay, for instance, if we look at the flower, we will see that there are flowers that uh, with numbers of petals such as 3, 5, 8, and so on and so forth. Okay, so now I want you to investigate this image. Okay, so for the first row, andyan dyan yung mga flowers natin. And then for the second row, we have the number of petals that represent each flowers. Okay, so for the first flower, okay, this is one, has one petal. Okay, for the second flower, has two petals. The third flower has three petals. Okay, for the fourth flower, has five petals. For the fifth flower, has 8 petals, 13 petals for the sixth flower, and then 21 petals for the seventh flower, and then for the last flower, it has 34 petals. So, what is the connection of those petals in our topic today? Okay, so and even in the spiral pattern that we have a while ago. Okay, so those are what we call the Fibonacci sequence. Okay, the spiral pattern, and even here the sequence that we have here, the 2 3 1 2 3 5 8 13 21 and 34, those are what we call the Fibonacci sequence. Okay, so let us first define what is Fibonacci sequence. So let us dig more about Fibonacci sequence. Okay, today, 100 years later, this seemingly arbitrary progression of numbers fascinates many who see in in a clue and everything from human beauty to the sugar market. So while those claim remains unproven, it is curious how evolution seems to favor these numbers. This Fibonacci sequence. Okay, Fibonacci numbers even appears in petal counts, especially Okay, so sa mga daisies. Okay, so yung kaninang pinakita ko sa inyong petals, di ba, meron din tulips, may different kind of flowers. Pero the Fibonacci sequence, makikita mo siya, the Fibonacci numbers, makikita mo siya sa petals ng daisies. Okay, so ngayon, paano at saan nagmula si Fibonacci sequence? Okay, so yung tao na nakikita niyo yan, siya ay isang European mathematician of the Middle Age. Okay, his name is Leonardo Pisano, or simply say that Leonardo of Pisa. Pisano means Pisa, so Leonardo Pisano means Leonardo of Pisa, because he was born in Italy around 1175. Okay, so Fibonacci sequence is a short word from Latin term Filius Bonacci. Okay, meaning the son of Bonacio. So meaning, si Leonardo Pisano or Leonardo of Pisa ay anak ni Bonacio. Okay, and then the Fibonacci comes from the word Filius Bonacci, or simply Fibonacci. Okay, next is he is the one who discovered the sequence of number in nature. So siguro habang naglalakad siya sa daan, ay nakakita siya ng petal, o isa petal nito ay nakakita siya ng mga bulaklak, and then he seemingly noticed that one flowers has one petals, and then yun, sa observation niya, nag-form ng Fibonacci sequence. Okay, next. So Fibonacci sequence is an order list of numbers that form by adding the preceding two numbers and begin with 0, 1, and 1. Okay, then keep adding the previous two numbers to get the next one, in which cases 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, and so on and so forth. Okay, so si Fibonacci sequence daw, Fibonacci sequence is a ordered list. Pag sinabing ordered list, siya ay numbers, listing of numbers, pero nag-start siya from 0 and then 1, 1. Okay, paano nangyari yon? Okay, so it gives us the following like this one. Okay, so tingnan natin. Okay, so dito, let's start with 0. So 0 plus 1 is equals to 1. Ito yun. And then 1 plus 1 is equals to 2. 1, okay, 1 plus 3, 1 plus 2 is 3. Okay. And then next is 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13. 8 plus 13 is 21. 21 plus 13 is 34. 21 plus 34 is 55. And so on and so forth. So, ganun yung sinasabi sa Fibonacci sequence. Sabi nga dyan, it is formed by adding the preceding two numbers, and it begins with 0, 1, and 1. So, dito sa Fibonacci sequence that we have at the bottom, start with 0, 1, 1, and then kapag inad natin yung 0 and then 1, it will sum up by 1. 1 plus 1 is 2, and so on and so forth. Okay, so iyon si Fibonacci sequence. Okay, statistically, Fibonacci numbers do appear in lots of botanies. So, for instance, if you look at the bottom of the pine cone, you will often see spiral in their scales. So, you will end up counting that, but those spiral usually find in Fibonacci numbers. If you count the spiral in the other direction, you will find that the adjacent Fibonacci number, it is the same with how the seed of sunflower head arranged, and if you count the spiral of each direction, you will often find two adjacent Fibonacci number as well. Pag sinabing two adjacent Fibonacci number, yung magkatabing number yung makikita natin. So, tingnan natin at examine the pine. Okay, bottom ng pine. Okay, for further explanation, kindly watch these links below. para mas lalo niyo maintindihan yung sinasabi ng Fibonacci sequence about the bottom of the pine. So ito yon. We're going to count uh, yung mga seed. Ito medyo hindi accurate yung arrangement ng mga lines. So bibilang siya sa 8 pag papaganon. Okay, yung mga seed niyan or yung mga ano niyan, mabibilang mo yung 8. And then dito naman, kung pakano naman yung bilang mo, okay, ang bilang niyan ay 18. Then 8 and 8, 13 pala, sorry. 8 and 13 are both adjacent to the in the Fibonacci numbers. Okay, next is ito namang sunflower seed. Okay, for further explanation, again, kindly watch the video below and andyan yung link. So, kung bibilangin natin pag ganitong way, so it will count 21 numbers, and then kapag naman going to the left, it will form 34 numbers. It will count 34 numbers. Okay, so next. Now, let's talk about the golden ratio. So, di ko alam kung narinig nyo na to, or first time yung marinig to. Okay, so sa golden ratio, it defined as this one. If we're going to examine further the relationship on ratio of one Fibonacci number to another as it is progresses, is bound to arrive the value discovered by the Greek even way before Fibonacci or pi. Okay, so, and also known as the golden ratio. Ano ba yung golden ratio na tinatawag dito? Okay, next. So, golden ratio is a special number approximately equal to 1.618. So, later, we will going to discover bakit siya 1.618. Okay, next. It is also equal to the irrational number 1 plus square root of 5 all over 2. Okay, next is named after the Greek sculptor Phidias, and then symbolize the Greek letter P, which is the lowercase and then the uppercase. Okay, so earn names like divine and golden because it has very unique properties in mathematics and geometry and appears as surprisingly numbers and place in nature. So, ang basa dito ay pi, hindi pi. Yung pi na isa pala, ang pi na isa is yung 3.1416 and so on and so forth. So, yun yung ratio ng circle. Pero itong pi na to, ibang ano to, golden ratio naman to, which is applicable in mathematics and then in geometry. Okay, so let us see kung paano siya naging 1.618. Okay, using the golden ratio. Pag sinabing ratio, ang operation involved here is division. Okay, so di-divide natin yung mga Fibonacci sequence. So let's start with this one. So 1 divided by 0 is undefined. So 1 divided by 1, ito yun, is equals to 1. Okay, 2 divided by 1 is equals to 2. Okay, 3 divided by 2, and that is 1.5. And then 5 divided by 3, that is 1.667. 8 divided by 5, so that is 1.6. Okay, next is 13 divided by 8, so we have 1.625. 21 divided by 13 is 1.615. 34 divided by 21 is 1.619. Next is 55 divided by 34, so that is 1.61. 89 divided by 55, so that is 1.618. 144 divided by 89, so that is 1.618. Okay, so 233 divided by 144, so that is equal to 1.618. So 377 divided by 233 is 1.618. So as you observe, mula sa Fibonacci 10, sequence 10, and so on pababa or pataas yung sequence, nagre-result siya sa 1.618. So that is why it became the golden ratio. At makikita mo yan, hindi lang sa mathematics, kundi sa ibang geometric figures. Okay, golden ratio in architecture, art, and nature. So, tignan natin. Okay, so sa sculptor na to, okay, golden ratio or the 1.618 is considered to be a aesthetically pleasing proportion. In fact, the number of views by famous Greek sculptor Epictetus, he proportioned his art with approximately linear ratio, the golden ratio, which is 1 is to 1.618 to illustrate the idea of physical perfection. Okay, so yung 16.8 pala na to, 1.618 pala na to, rather, ay ginamit ni Phidias para i-formulate yung perfection ng isang tao or physical perfection. Okay, next. But dito, some artists and architects believe that the golden ratio makes the most pleasing and beautiful shape. Okay, many buildings and artwork have the golden ratio in them, such as Parthenon in Greece, but it is not really known if was designed that way. Okay, so itong Parthenon na to, okay, so kung makikita natin, sabi ng mga mathematician, it forms using the golden ratio. Pero sabi nga dito, it is not really know if it is was designed in that way. So hindi natin alam talaga kung yung uh, image na to or architecture na to ay ginawa sa pamamagitan ng golden ratio. Pero makikita natin siya doon. Okay, next. Okay, the Great Pyramid of Giza is believed to be 4,600 years old, which has long before the Greeks. Its dimensions are also based on the golden ratio. Okay, so masarap pag-aralan ito at sarap i-validate kung talagang yung base niya ay golden ratio, nagpo-form ng golden ratio. Okay, so pero iyon yung according to the study. Okay, how about this one? Kilala niyo ba to? Okay, di ba si Mona Lisa? Okay, so yung spiral kanina na pinakita ko sa inyo, mamaya explain ko sa inyo kung bakit ganun yun at ano yung connection nun sa mukha ni Mona Lisa. Sabi dito, many artists who live after Phidias have used this proportion like Leonardo da Vinci in his painting Mona Lisa. Okay, so from here, ayan, so makikita natin na ay meron siyang golden ratio. Proportion to the human body, such as face, follows the divine portion. The closer the proportion of the body parts is to the golden ratio, and the more aesthetics and beautiful the body is. Okay, so tingnan natin to. Okay, so mula sa mga mata, sa ilong, sa bibig, okay, meron siyang golden ratio daw na makikita. Fibonacci relationship of human head. And then ito naman, mga sukat mula sa dulo ng daliri hanggang siko, ulo hanggang baywang, baywang hanggang paa. So, Fibonacci relationship of human body. So, dun din daw natin makikita. Okay, next is the golden angle. If the ratio is translated into geometry, like perhaps in circle, we can get what is known the golden angle, or 137.5 degrees. Okay, it is common knowledge that the circle has a total central angle of 360 degrees, and with the ratio of 1.1 1 is to 1.618, and one can simply derive an approximation of 137.5 degrees. So, hindi na natin siya i-derive, baka mas lalo kayong mabaliw. So, ibig sabihin lang nito, mula sa circle na merong 360 degrees, at gagamitin natin yung golden ratio na 1 is to 1.618, Okay, so if we're going to derive that ratio, we will get the golden angle, which is 137.5 degrees. Okay, so yun lang yung ibig sabihin. No? Itong golden angle na to ay makikita natin sa mga nature, gaya ng sa mga flowers. Sabi nga, this angle is widely observed in nature. So for instance, in plants, the most effective way to sprout or grow leaves on a stem, as what the most plants follows as their growth patterns. And if the new one will grow appear 137.5 degrees after the previous one. Kapag daw may bagong bunga or bagong umusbong na halaman or dahon, so meron siyang angle na 137.5 degrees. Okay, so doon mo makikita yung gold. Okay, so now let's talk about the golden rectangle. Kanina, golden ratio, golden angle, ngayon golden rectangle tayo. Sabi dito, golden rectangle, which side are the ratio of 1 is to 1.618. So, it is also evident in the most art forms, architectures, and even in nature. So, ito yung golden rectangle. So, as we observe, yung 1, 1, 2, 3 na to, 5, and then 8 na to are all in the Fibonacci sequence. Okay, so yun, parang ito, the Fibonacci sequence that we have here at the bottom. So yun yung 1, 1, 2, 3, 5, 8, 1, 21, at 13, 21, 34, 55, and then 89. So, para mas lalo nyo makita, ito yung animation niya. Okay, so iyon yung Fibonacci sequence. Okay, yung Fibonacci sequence, we have 1, 1, 2, 3, 5, 8, and then 13. And then, kapag connect natin at nag-form tayo ng arc, bawat opposite side ng rectangle na yan, makikita natin or makaka-form tayo ng spiral. Kaya kung papansinin nyo, yung sa unang slide natin, yung unang tanong na ano yung mga patterns na nakita nyo, may nakita kayo ng spiral pattern. Yung spiral pattern pala ay galing sa Fibonacci sequence. Okay, so Fibonacci, the more we look at the nature phenomena, the more we see the evidence, the golden ratio, and the golden angles. And it is often lead us to spirals. Ayan, mula sa halaman, hindi ko alam kung ano ito eh, kung ampalaya, di ba? Yung ampalaya meron siyang ganun. Ayan. So makikita natin talaga, and even sa natural disaster, ito yung bagyo sa pinakadulo sa baba ay spiral din siya. And even yung mundo natin, okay, yung Milky Way galaxy, okay, spiral form siya. Okay, next, so finding the end term in Fibonacci sequence. So alam ko ito yung pinakahihintay nyo, yung pagsusolve and then pagko-compute, di ba? Okay, so si Fibonacci, para malaman natin yung end term ng Fibonacci sequence, we're going to use this formula. Formulated, or what we call the Binet's formula for the end term of Fibonacci number. So here, f sub n is equals to, okay, so 1 plus square root of 5 of all over 2 raised to n minus 1 minus square root of 5 over 2 raised to n all over square root of 5. Again, so this formula is what we call the Binet's formula of the nth Fibonacci number. So, gagamitin natin yung number na to para malaman natin kung anong numbers yung magpo-fall sa n term. Yung n term, halimbawa 21 term. Okay, so ano yung number, ano yung Fibonacci equivalent nun? Okay, so for example, for you to understand. So find the 22nd term of Fibonacci sequence. Okay, so ngayon, magbibilang ba tayo na 1 plus 1 plus 1 plus 1? Ganun. So hindi. We're going to use this formula para malaman natin yon. So dito, we're just going to substitute n. Okay, kung ano yung term na hinahanap natin. So yung mga n na to, okay, ay papalitan natin siya ng 22. Okay, solution, n is equals to 22 kasi ito yung n term na hinahanap natin. Okay, substituting all the given or n to the formula. So ito na yon. So f sub 21 is equals to 1 plus square root of 5 all over 2 raised to 22 minus 1 minus square root of 5 all over 2 raised to 22 all over square root of 5. So if we're going to use the calculator, in solving that, we will get the result of 17711 or 17,711. Okay, so next, find the 15th term of the Fibonacci sequence. Okay, solution, Rn is equals to 15. Okay, substitute to the formula. So we have f sub 15 is equals to x plus 1 plus square root of 5 all over 2 raised to 15 minus 1 minus square root of 5 all over 2 raised to 15 all over 25. And we will get the result of 610. So bilangin natin. Okay, sa pagbibilang, we exclude 0. Hindi natin siya bibilangin as ano. Start tayo dito. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so ito yung pang 15 term. So 610. Okay, mag-step forward lang tayo. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So si 610 ang 15 term. Okay, so for your turn, okay, use Binet's formula to determine the 25th term, 30th term, and then 50th term in Fibonacci sequence or numbers. Okay, so pakisagutan yan on your notes, on your notebook, and then I'm going to announce uh, the answer in our GC or in our Facebook. Okay, so that's all for today. So this is the end of our discussion about the Fibonacci sequence. I know you learned a lot, and see you on my next video. So thank you and God bless.